Welcome back to Math Solver 1117. Today we are solving IMO 2024 problem 1. And trust me, it looks innocent, but it hides a deep and beautiful mathematical truth. Can you find all real numbers alpha such that this surprising condition holds for every positive integer n? Was till n, because this trick we will use might just becomes your new Olympiad mathematical weapon. Let's dive in. Problem is that determine all real numbers alpha such that for every positive integer n, the integer alpha plus 2 alpha up to n alpha is a multiple of n. Note that mod of z denotes the greatest integer less than or equal to z. For example, when we take minus 5 which is equal to minus 4 and 2 is equal to 2.9 or equal to 2. We will solve this step by step in very easy and simple way. So we will start the solution of this question as, first of all, consider the given Sn is equal to the alpha plus 2 alpha plus up to so on n alpha. Then this problem states that every positive integer n such that s of n is a multiple of n. So we will prove this as, first of all, case 1, that take n is equal to 1. If we take n is equal to 1, we will get s of 1 is equal to the alpha. So you will write, since s of 1 is be a multiple of 1, this condition is always true. Condition is always true. So alpha be an integer. So this is the first base case, that n is equal to 1. Now we will do this for case n is equal to 2. So for n is equal to 2, we will find that s of 2 which is equal to the alpha plus 2 alpha. So the sum whole should be a multiple of 2. If alpha is an integer, then s of 2 which is equal to the alpha plus 2 alpha, it will become alpha plus 2 alpha is equal to the 3 alpha. So which is a multiple of 2 only if alpha is an even integer. So condition is that which is multiple of 2 only if alpha is an even. If alpha is an even, then this condition satisfied. Otherwise, if alpha is not an even, let's suppose alpha is equal to not an even, maybe m plus epsilon, where m is an integer. This condition is when alpha is not an even number. So we suppose alpha is equal to m plus epsilon, where m is an integer, and condition for epsilon is between 0 and the 1. Maybe 0.1, 0.2, 0.3, any number that is greater than 0 and less than 1. So we will write S of 2 is equal to the m plus for alpha condition m plus epsilon. So for alpha we use just m, and then 2 alpha becomes 2m plus 2 epsilon. So let's suppose that m plus 2m is equal to the 3m and plus 2 epsilon. Now we take the value of the epsilon is between 0 and 1. So we can suppose that if 0 is less than epsilon and epsilon is less than 1 by 2, this is possible because it lies between 0 and 1, then S of 2 is equal to the 3m, which is the multiple of 2. Condition is that which is multiple of 2 when condition is given that when m is even. M is even, then this is the multiple of 2. But if 1 by 2 is less than or equal to epsilon and epsilon is less than 1, because epsilon is between 0 and 1, so this condition is also possible that epsilon is equal to the 1 by 2 and less than or equal to the 1 by 2 is less than or equal to epsilon and epsilon is less than or equal to 1. So in this case, when this condition, we have S of 2 equal to the 3m plus 1. So 3m plus 1 is not a multiple of 2. We will write is not multiple of 2. Now we will solve the general case for this. So we will write the general case of this. Let assume alpha is an integer. Let alpha is an integer, which shows that if it is an integer, then S of n, that is equal to the alpha plus 2 alpha up to so on n alpha. Now you can take alpha as common from this. So remaining terms are 1 plus 2 plus up to plus n. So this will become alpha into n plus 1 by 2. We can write this as, so for Sn be a multiple of n, it is necessary that n into n plus 1 alpha into n plus 1 by 2 must be an integer. This should be an integer. So this is true for all values of n, for all n. Now when suppose n is equal to 1, it's mean alpha into 1 plus 1 divided by 2, which gives alpha. N is equal to 1, this is alpha, which is an integer. So when n is equal to 2, it's mean alpha into 2 plus 1 divided by 2, which means 3 alpha by 2. So which must be an integer. Which must be an integer, and condition is also that alpha must be even. Must be even. If alpha is even, like this is 4, then 3 into 4, 12, 12 divided by 2 gives 6. But if it's odd, that 3 into 3, 9 by 2, so that will be not an even number. So alpha must be even. Let's suppose alpha is equal to 2k. Then we get S of n is equal to, in alpha we put 2k into n plus 1 divided by 2. So this will become 2k into this will become 2k into n plus 1 by 2 and equal to k of n plus 1. So this is equal to 2 and 2 are cancelled out, so k of n into n plus 1, which shows that which is always multiple of n. So this is the complete proof of this first International Mathematical Olympiad 2024. If you learned something new, subscribe Math Solver 1117 for more mathematical videos and share with your maths students. Best of luck for your exam. Stay tuned.